Hello everyone. So welcome to my Method 24. Welcome to my Method 25 Final Exam Review Part 1. And today we're gonna talking about the basic integration technique and some like easier applied problem in the final exam. And now it's 1:40 p.m. because I need to just see if I can write everything good and testing like audio quality, everything. So that's why I just started inside of 1:40, 10 minutes late. So instead of ending by 3 o'clock, I'm ending by 3:05. And I apologize for everything. Okay, let's get started. This will be method 25. Final exam review, part 1. And so this part 1 is like talking about like easier stuff. So it's more like integration techniques or like a net change theorem or like velocity problem. And in part 2, I will discuss more applied problem. And for third part, I'm going to mainly focus on chapter 9, which is 9.3 and 9.4. I think I need to get started right now. So I just randomly chose some exam from past final exam, and I think it is quite important just to practice all the problem and just make sure I covered every type of integrals that it makes back on the final exam. So the problem 1, it's from fall 2017, and then problem 2a is this integral. Okay, I think now just to pause, maybe pause the video just to think is what technique you should use. I think this, so take a look with this integral. We have like this x inverse tangent. I think this is like a product form. So when everything's in product form, you either use U substitution or trig sub or trig integral or integration by part. But this function is being obvious. Very obviously is use integration by part. Why use IVP? Because there's inverse tangent, inverse trig functions. Well, because it's a product form, it is inverse trig. If it's only inverse trig, just trig is 1 times inverse tangent or inverse trig. So when doing IBP, we need to choose U, du, dv, and v. So choose U something you can just find the derivative immediately. So you know the derivative of inverse tangent is 1 over x squared plus 1. Then we choose U equals the inverse tangent, then du it is x dx, then find everything else, then use U substitution if it's necessary, and partial fractions. So for this problem, we need to the U it is inverse tangent. Du it is 1 over x squared plus 1 dx. we have dv it is x dx, the v it is 1/2 x to the square. Now let's do IVP. So the most important thing for IVP is you just write u and dv. Just you make some, just you just make du nice looking, or there's like better way to integrate. But sometimes you might need to use IVP for more than once. So that's like another case that we will discuss in a later review. So now you have is uv, but this is a definite integral. So what you will get is the answer, and it's a numerical answer like number. And if you need to use substitution or partial fraction later in the integration process, make sure they change the bound. So you have gonna be 1/2 x squared times inverse tangent of x. This now you don't need to change the bound because it's too early, because you just make the, because u and du here is not for u substitution, they're just for, okay, just use for the by part, just to split it into two different parts, and you know what to integrate and what to multiply in like the later integration process. Now it's just the 1/2 is a constant, which is a pole constant now, but just because it just makes integration easier. And this is like a new integral. You have x way on the top, x plus 1, bottom, dx. If it's like the top and bottom have the same higher degree of power, use long division first, then partial fractions. So we do long division, then it's partial fraction decomposition. PFD, I call them partial fractions. So let's, and then after PFD, you will get and make a U substitution if it's a property. Then it's like, yes, U sub. Then you got like arctangent of a square root of 3. You can know the trig values here, and then you will get what the final answer is. That's for the first problem. Let's move on to number 2. It is if, so it's the same exam, but if you have is f prime of x, it is 1 over r squared minus x squared 3 over 2, and f 0 is 0. Now you need to find the expression of f of x. I think this is like just to make it do the tricks up, because like you have a r squared minus x squared. This is a perfect a squared minus x squared. In this case, r is a constant. So don't just freak out that why does like r and x here is like too many variables. I think it's a function of x, so r is a constant. And trig sub will be the technique will be used for this integral. And this is going to be a squared minus x. The x squared case is here. And we have a squared minus x to the squared. And we need just to find like the cases that we use for trig sub. So a squared minus x squared, then x equal to a sine of theta. And just for this integral. And we just we replace r as an a, and then we do the integration, and now we need to find the definite integral of the function that we need to substitute the initial condition back there. So this is the indefinite integral. And we just do this process, just set up an integral. 1 over r squared minus x squared 3 over 2 dx. This is what we need to do. And then we just sub in actually r sine of squared, r equals to sine of theta, then just do normal trig sub stuff. And then we just do 1 r squared minus r squared sine squared. So yeah, square root of theta 3 over 2, and then it's gonna dx gonna be a cosine theta d theta. And this r squared 1 minus sine is cosine squared, the cosine cubic here. So to make sure you know the trig identities here, just remember what is 1 minus sine squared, what is tangent squared plus 1, and what is secant squared minus 1. So now we have this. So we have r squared we have gonna be r to the cubic here. We have as r cosine theta d theta. And then we just cosine to the cubic, the cosine, and they're gonna be this is 1 over r squared, so it's gonna be r to the negative 2, 1 over cosine of square. It is secant squared. So it's gonna be 1 over cosine of theta d theta. And then what you have is this is gonna be r to the negative 2 secant squared of theta d theta. Just now look at this function is easier because now you know what is antiderivative of this. Do the antiderivative and the r to the -2 just to pull out the constant. Then just to do, then put back in this. That's just for f of x. This is the first page. Okay. It's just, okay, so let's do more integrals. The third problem is an indefinite integral. It is 1 minus x over 1 minus x to the squared. Okay, this one just very tempting you to do the u substitution, but u sub doesn't work here. So what you do is the trig sub. This is an obviously a squared minus x squared case, trig sub. So we let x equal to 1 sine of theta. Then do the trig sub, then dx, it is cosine theta is theta. Now just rewrite the new integral. Make sure x, so for this is 1 minus x, it is going to be negative x plus 1. So this is going to be 1. So there's going to be negative x, going to be negative sine of x and plus 1. So be careful, write the numerator, because like sometimes numerator may be not very nice. This could be rewrite the whole thing. It's going to be negative sine of theta plus 1. And this is going to be 1 minus sine squared. And then I have this, yep, I have this, just this is cosine squared, going to be cosine. Cosine squared becomes cosine theta, then cosine theta d theta. This canceled, very nice integral, right? And then it turns out a very nice integral. Yep. It will be like the antiderivative of, well, just don't expand this out because you can just cancel it. Since this is a trig sub by the indefinite integral, so make sure you express sine of theta in terms of x. express some data in terms of x. Okay, let's move on to the next one. It is winter 2012. Another integral that you might see found it is a partial fraction integral. Okay, so number 4 is a partial. Number 4 is a PFD. So I write them as so they're going to be x squared minus x then plus 8. The bottom is going to be x to the cubic plus 4x. This one, it is just a reduced integral, so you don't need long division to it. This already just so this already like the reduced form. Factor the denominator. Then do the PFD. So we do this. Factor x out because x is like the what we can factor. This is an irreducible quadratic. So what we should do is going to be a over x and then plus bx plus c over x squared plus 4. Then we multiply the thing and we solve for a, b, and c. Then do u substitution if it's necessary, because this you might need to do a u substitution here. So you just do u substitution. And what we have is going to be x squared minus x plus 8 is equal to a times x squared plus 4 then plus bx plus c then x. And then we solve like system of like linear equation. We have a plus b, it is 1. Cx, it is c going to be negative 1 because it's going to be negative 1x. And then 4a is 8. You solve it by a gonna be 2, b it is negative 1. C it is negative 1. We rewrite the new integral here because we solve this ABC and we just plug back into it. A gonna be 2 and plus b gonna be negative 1. It's gonna be gonna be negative x then just negative 1 over x squared plus 4. Wait, this time just don't use up for this. There's 2 individual integrals here. Just this split up the integral. Because this is the inverse tangent you have is you just split integral, even though, wow, this is the inverse tangent. Fantastic, right? So then do inverse trig, and then do like use substitution, then just solve everything. That's just for this integral. Well, I will solve this for you. It's gonna be 2 natural log of x, and then minus like natural log of extra plus 4. And then this is inverse tangent squared, like the integral. A equals to 2, so going to be a minus 1/2 over inverse tangent of 1/2 of x plus constant of integration. So all the indefinite integral, you need to have the constant of integration here. And then head to the. Okay, so this is going to be a hard one. So this is a hard integral. Another IBP, I think. So is x plus ex plus natural log of x. Okay, so now you know the trick, right? Every time you see a natural log of e of x and it's a multiply of everything, do IBP. We need to expand, multiply it, and just split the integral. This time we need to do 2 IBP in a row. So this is the case I discussed that sometimes we might need to use IBP more than once. So here's the case. You know, IBP is okay, but it's sometimes just it's like annoying if you get like infinity loop to just like and then it's gonna be x natural log of x. Okay, for this one, choose u equals to x. This one choose natural log of x because you know the derivative of natural log is 1 over x, right? It's the IBP. And then again and again for that one. and then do IBP, then you're all set. Gonna be UV, so gonna be XEX, then minus VDU, plus this UV minus VDU so it's gonna be X dx. The total we're gonna result the integral it is XEX minus EX plus 1/2 x squared to natural log of x. This is going to be 1/4 of x to the squared. The minus 1/4 of x to the squared plus constant of integration. Then we're done with this. And we're done with this integral. Nice job. Number 6 is not going to be fun. It's not a trig sub. Are you ready for it? Let's ready for the challenge. It's a trig sub by completing the squared. Okay, x squared plus 2x plus 4, and you know it is this, right? So x squared plus 2x plus 4, it is x squared plus 2x plus 1 plus 3. I know this is gonna be nasty, but oh well. Squared. And then you move to this. Oh, I mean, this is a very, I hate this kind of a tricks by coming square because they're tedious, but they're not trick once you just get like what you sub. So this is x squared plus a squared. So it's the tangent of x. So you subtangent. So this is x squared plus a squared cases. So we sub x plus 1, it is equal to square root of 3 of tangent theta. Be careful for this definite integral. You need to make a u substitution when doing the trig sub. So 2 plus 3 equals the square equal to radical 3 of tangent theta. You find the theta, then find a new integral. So let's do a calculation here. So for 3 equals to 3 tangent. So 3 equals to like the radical 3 of tangent of theta. So for theta, upper bound is pi over 3. So if 3 equals radical 3 of tangent of theta, then theta is a pi over 3. If 1, it is square root 3 tangent of theta, then what is lower bound? Just try to find what is lower bound. It's pi over 6. So you should construct a new integral that is upper bound pi over 3, lower bound pi over 6. For 6, we have it's going to be 1. And then don't forget, like integrand is going to be square 3 secant third of theta. The theta here is going to be 3 tangent square plus 3. So going to be 3 secant squared. And then you do all like the simplification here. Well, pi over 6. That's gonna be 1 over gonna be 3. So it's gonna be like 3 of secant theta, then like 3 of secant squared of theta. Now you have a nicer integral. And it's gonna be pi over 3, pi over 6, just like canceled secant theta here. Now you just do the antiderivative, and then the secant integral, and they just do like a U substitution here. And you, I know it's kind of a nasty integral, but there's no way you can just yep. So gonna be like a natural log. Secant squared of theta and a plus tangent of theta and pi over 3, pi over 6. Then that's it. There's no need, and just compute plugging power 3 and power 6 there, then that's the answer. Yep. That is all what you need to do. Let's do another integrals here. This one's going to be fall 2019. So number 7 here. I think we haven't done a trig integral, right? So let's try one. So going to be pi over 6 and 0. 16 cosine squared of 2x. then sine squared of 2x. Okay, so this one is first step is just doing u substitution. So it's u sub is the first step. So u sub is the first step we need to do. So u substitution, change the bound. So what we have is going to be pi over 3. And then lower bound is unchanged. Okay, I think this is like the half angle identities, like very important trig identity is like rewrite if both the sine and cosine have an even same power, rewrite using this trig identity. This is very important for this integral. This time x is just the u, and then we write them as a multiply here. So it's pi over 6, but unchanged, so it's going to be over 3, and the arrow going to be 8. So it's going to be 1/2 plus 1/2 of cosine 2u. Then minus, and then we do multiply, and then we expand. It's like more thing than even know that what it and then what need to do. Rewrite it again. Minus, shouldn't we? Half over cosine of 2u du. Note that this is 16 minus times 1/2, it is 8. Now we expand. 8 is a constant. We pull them out because I don't want to make them miss it because of the 8 to below everything here. We move 8 in front of integral. Over 3, and we had just 1/4. Minus 1/4 cosine 2u. And then we plus 1/4 cosine 2u. Minus 1/4 cosine squared 2u. Du. Could notice this apply here again. We rewrite it again. I hate this, you know. minus 1/4 cosine of 2u du. Then rewrite for this again. You're just still doing this thing here. 1/4 cosine of 2u, we just put a 1/4 out here. Just get rid of constant. Then do antiderivative. Until this is out. And then it has 2u. It is gonna be 2/pi/3 and then 0 here. And it's gonna be 1 minus cosine 2u. And it's gonna be half. Then plus there's gonna be cosine of 4u, I think. I think since getting here, just make sure that there's no, and then just do like another kind of u substitution, then you're done with this integral. Man, I know this is hard. Okay, let's back to it. So fall 2019, the same exam. I'm going to go over. So this is the last integral I'm going to go over before jumping to the net change, and it's an integration by part. So number 8. This is IBP, and is the integral of natural log x plus 1 dx here. So if you ever see natural log, regardless of what the hell is inside of the inside natural log, use IBP. Use a chain rule here. So if u is going to be natural log of x squared plus 1, du is going to be 2x over x plus 1 dx. Then dv is 1 dx, v is x. And then now just to know that due to IBP, and you might need some partial fractions or long division. This is the one thing you might need to think when do some like integration by part. There's some integral like inverse trig, like especially inverse tangent and natural log. Those are you need to pay attention to if you need to do like a partial fractions or like a long divide. And then we have this integral of uv v du. uv is right here. X is natural log of x squared plus 1 minus v du. 2 is a constant. gonna be x squared or x squared plus 1 dx. Wow. This case, I bet you have to do like a long division, else you're not going to solve the problem anyway. I'll do long division for you. By 1 minus x squared plus 0x minus 1 plus 1 . So now this case is going to remainder and divider. So we're going to integral as this. It's just to make sure that your do long division and right and right. Just leave this unchanged. This is the indefinite integral, so there's no use substitution here. Minus 2 1 minus 1 over x squared plus 1 dx. Now you know how to do the I think the rest of the integral, right? And we just need to do it as x hat natural log of x plus 1 and minus 2, then plus inverse tangent of x by constant of integration. Okay, I think that will be all for like integrals part here. I solved 8 different type of integral, kind of just to go over some integration technique and just do a like brief overview here. So do integration technique summary. Okay, so let's do different type of integral here. So type 1, it is IBP. Use IBP when you have those cases. 1A inverse trig. The exponent. The third case is like natural log. Or it's like a product function. Case number 2 is the trig integral. Odd sign. You have an odd sign. Pull on one sign. odd cosine. Pull out a cosine. Okay, C is even power, use half double angle identity. Use half the double angle. Okay, D is even, secant even power. Pull out this secant square. Was odd on tangent at least one secant. You need to pull out like a tangent secant. And then let's do some trig sub summaries here. Trig sub. If it's like non-factorable polynomials, non-factorable polynomials. Case B is a squared plus x squared x equal to a of tangent of theta 3c. It as we have is a squared minus x squared. Then we have this case is x equal to a sine of theta. If we have the fourth cases, it is x squared minus a to the squared. We sub x equal to a secant of theta, and make sure to complete the square. Completing these square, yes. And then it's a partial fraction, it's a rational function. The fourth case is like a long division. It's just a PFD. Okay. let's wrap up on this integral technique. Let's move on to net change theorem. The total displacement and total distance traveled. The net change theorem. This is a big concept. So the total displacement can be negative, can be a zero, can be positive. Why? Because total is the total, is the how much you moved, it's the total steps. So the total displacement is how much you moved over a period of time you can move backward, forward, or not move. But you consume calories, consume energy. So if you start at point A, move right 25 meters, then move back 10 meters, and point B here. And then you move up 40 meters to point C. So the total displacement is 40 plus 10 plus 25, it is 75 meters. No, the total gonna be 55 meters. Move back is negative. Move up, positive. Not move is a zero. So the main difference is if you move back, you have a negative displacement. So another case is you start point A, move forward for 15 meters to point B, move back for 30 meters to point C. What is the total displacement? Move back 30 meters is negative 30. Move up, positive. So total displacement, it can be negative 15 meters. So total distance traveled is like another different concept that is introduced in Calc 1. No, in Calc 2. Number 2, it is total distance traveled. Is always positive. Just regardless of the direction. So if we have person travel from point A, 40 meters. You travel back 20 meters. You travel up 80 meters to point B. What is the total distance traveled? So this is distance traveled. So every move counts positive. Every move counts positive, not negative. So 40 plus 20. So 20 is also the distance, total distance travel you moved. So total distance traveled, it is 140. If you estimate total displacement, it is 40 minus 20 plus 80 is 100. That is the main differences. So when solving for total distance traveled, you have to also make sure that you don't produce a negative distance traveled. Because negative can be displacement. So if you're moving backward from origin, you travel 25 meters, but it's backward. So you're 25 meters away from the origin. Let's find an example because we have time left. Is fall 2019 final exam. It's the same exam, but not the same question. So the number 9. We given the acceleration, initial velocity. Find total distance traveled, TDT. So TDT, it is what we need to find the velocity functions, integrating the velocity functions. So TDT over a fixed period of time, and it is B over A, absolute value, dt here. So the first step, it is find the velocity function based on the initial based on the initial conditions. So this one we have is AT to 2t plus 6. The VT is equal to t squared plus 6t plus c here. And we have the given initial condition. It is VO equal to negative 7. So when t equals to 0, VT is negative 7. Then solve for C. C is negative 7. So we can find out it's like VT, it is t squared plus 6t minus 7. This is the VT. Notice that this is a factorable polynomials. So make sure that you have to make sure the function is always positive. So you need to factor VT. Which interval this is under, which interval there's positive, which interval it is negative. You need to just to figure out. So now is factor VT. Spell out an integral. So t squared minus plus 6t minus 7 is going to be t minus 1, t minus 6. So over 1/6, VT is negative. And we need to find the total distance traveled from 0 to 2. And we need TDT from 0 to 2. We need to split up like t equals to 1. So we need to split up the integral, and then we evaluate the integral. From 0 to 1. Another integral we have going to be 1 to 2. Evaluated integral, then that's total distance traveled from 0 to 2. Also, I'm just gonna kind of just elaborate more on this that change. So for total distance traveled, it is okay. Let's do more example. I think last one, it is autumn 2013, the third problem. We are having the velocity function. This one's easier, but just need to find the TD versus TDT. If we want to find the TD, just evaluate the integral. So here's the main differences between TD and TDT. So TD just evaluates the integral. But for total distance travel, TDT, we need to split it up, factor velocity function, then evaluate the new integrals. So distance traveled. Is TDT. Absolute value sign. That's the main differences. So we already have this velocity function, and we need to find the total TD and TDT. T squared minus minus 5t plus 6 is going to be t minus 2, t minus 3. Oh, wait, I found an error here. So it's going to be t plus 7. This is an error, just to call this. I caught an error. Should this be factored? So the new integral is split it up from, well, 1 is correct, but just like we need gonna be reversed it. Gonna be negative 7 and 1. So from 0 to 1, it is negative. And this is the correct integral. Factor gonna be 2 and 3, it is negative. So we split them into 3 integrals. So for TD from 0 to 4, we just evaluate this integral. But for TDT, from 0 to 2, perhaps gonna be plugging for 3 gonna be like 5t minus t squared minus 6 dt plus from like a 3 to 4 gonna be t squared minus 5t plus 6 dt. That is how to solve like the ddt and td. I think this will be like a part 1 of my reviews. Is I don't solve all like the problems because it just provides like how to approach those problems, because the main point of the final exam is like you know what technique to use and how to do well on the exams, and you just know how to apply different integration technique or TDT or TD on the final exam. And it's like 3 or 4 p.m. and is ended what I expected. And thank you guys for watching, and see you guys on part 2 of my final exam review. Thank you so much and have a great day.